Welcome to day 6. Today we're covering one of the most important, yet least glamorous parts of building any data-driven system, the essentials of data cleaning. So let's start with a situation I'm sure you've been in. You spend all this time building a really clever model, but its predictions are just wrong. It feels like the logic is perfect. So what's going on? Why do good models produce bad results? Well, it almost always comes down to the first and most important rule in data science. Garbage in, garbage out. No matter how sophisticated your model is, it's completely at the mercy of the data you feed it. Bad data in will always mean bad results out. By the end of this, you'll know how to spot the signs of dirty data, how to fix it, and how to turn that raw, messy information into your system's most reliable asset. A good way to think about this isn't as a chore, but more like a doctor diagnosing a patient. Because let's be honest, raw data is almost never healthy. Our job is to run the tests, find the problems, and apply the right treatment. So, just like any good doctor, we start with a diagnosis. We have to understand what's wrong before we can fix it. Generally, these data ailments fall into 3 big categories. First, you have structural errors, which are all about formatting and consistency. Second are content errors, which are problems with the actual data values themselves. And finally, there are completeness errors, which are basically just problems of absence, things that are missing. Now that we know what to look for, let's talk about treatment. What are the essential techniques we can use to clean up our data? Let's start with those structural errors. The most common one by far is having inconsistent formats. This is when the exact same kind of information, like a date or a name, is stored in a bunch of different ways. Now, you and I can see that Feb 1, 2025 and 01/02, 2025 mean the same thing, but a computer just sees 2 totally different text strings. Same with product A in title case versus all lowercase. The treatment here is standardization. You pick one single format and you convert everything to match it. It's simple, but it's absolutely crucial for accurate counting and grouping. Okay, next are content errors. The 2 big ones here are duplicates and outliers. Duplicates are pretty straightforward. They're just identical records that can mess up your counts. Outliers are a little trickier. They're extreme values that are way different from everything else in the dataset. And this chart is a perfect example of an outlier. Imagine these are your monthly sales figures. That one giant bar could be a huge, legitimate sale, or it could be a typo or someone added an extra 0. If you just calculate the average without investigating that spike, your result will be completely misleading. And that brings up a really important point. The right way to handle an outlier isn't always to just delete it. The first step is always to investigate. Is it a data entry error, or is it a real but very rare event? An error should be fixed, but a valid extreme event might just be the most valuable insight in your entire dataset. And finally, our third ailment, completeness errors. This is just a formal name for missing data. You see it all the time, those empty cells in your spreadsheet where a value should be but just isn't. Handling missing data is a bit of a judgment call. First, you have to quantify the problem. How much is actually missing? Then you strategize. If it's just a tiny fraction of your data, maybe you can just delete those rows. But if it's a lot, you might need to try imputation, which means filling in the gaps with a reasonable guess, like the average value. Then you execute your plan. Okay, so we've diagnosed the issues and applied the treatments. Now we have clean data. Let's talk about the payoff. Why does all of this work actually matter for the systems we as engineers and data scientists are building every single day? Well, because clean data is the bedrock of any reliable system. It stops your AI models from making weird, unexplainable errors. It makes sure your business forecasts are actually based on reality. And frankly, it means you spend way less time debugging strange issues and more time actually innovating. It creates consistency that you can trust. Think about a simple e-commerce system. Clean data means you're not accidentally sending the same marketing email to a customer 3 times. It means your inventory count is actually correct, so you don't sell products you don't have. It leads directly to a better, less frustrating experience for your users. So to summarize it all in one sentence, data cleaning is the systematic process of diagnosing and treating errors to ensure your data is accurate, consistent, and reliable. The one key takeaway is this. Your model is only as good as your data. High-quality data is the non-negotiable foundation for every successful system. Tomorrow, we'll build on this clean foundation as we explore the next crucial step in data preparation: feature engineering